Hello everybody, and welcome back to another geometry lesson. Today we're going to be learning about pairs of angles and how to describe them. So our main goal today is to talk about different ways we can combine or utilize two angles together. Let's start off by talking through a couple definitions here. Firstly, I want to talk about what it means for two angles to be complementary. So complementary angles, or two angles are said to be complements of each other if they add up together to make 90 degrees. So let's say I have a 40-degree angle here and a 50-degree angle here. These two angles, if we were to combine them, would make 90 degrees. So that's why we call them complementary. So it is two angles whose sum of their measures is 90 degrees. Perfect. What we might say is that one angle is the complement of the other. So like angle 1 is the complement of angle 2. Similarly, we also have something called supplementary angles. And these work a little bit differently. Supplementary angles together add up to make 180. But it's still sort of the same idea. If we were to put these two angles together, for instance, a 120-degree angle and a 60-degree angle, they'd make 180. So, supplementary angles are two angles whose sum of their measures is 180 degrees. And once again, we can say that one is the other's supplement because they need each other to make 180. Next up, I want to talk about what it means for two angles to be adjacent. Now, here's where things get a little bit weird. I'll give you the definition first, though. Adjacent angles are two angles that share a common vertex and side. Two angles that share a common vertex and side. This is where it gets a little bit strange to describe, but let me put it this way. Let's say I have an angle that I'm going to call, let's do angle A, B, C. And I wanted to make an angle that is right next to this one. Well, the easiest way to make a new angle is for them to share a side. So maybe I make another ray here and call it point D. We actually have two angles here that combine to make a bigger angle. We've got the green angle, ABC. We've got this purple angle, CBD. And they combine to make a big angle, ABD, if you ignore this middle line here. So adjacent angles are just two angles that share the same vertex. They're connected at point B, and they share a side. Both of these angles have ray BC as part of them. Cool. The last two definitions are a bit different. They only happen in very specific circumstances, for instance. A linear pair is what happens when we combine the definitions for adjacent angles and supplementary angles. A linear pair is a pair of two adjacent supplementary angles that form a straight line. It's a pair of two adjacent supplementary angles that form a straight line. So the basic premise is you have to have them both add up to make 180. Maybe I have a 140-degree angle here and a 40-degree angle here. These would be a linear pair since this bottom line is a straight line. Last but not least, we have vertical angles. Now, the formal definition for vertical angles is a bit weird, so I'm going to give you an alternative definition. The alternative definition is this: angles formed opposite from each other across the intersection of two lines. Angles formed opposite from each other across the intersection of two lines. So if I've got two straight lines here that cross each other, vertical angles are found across the angle from each other. So for instance, this top angle and this bottom angle. The best part about vertical angles is they end up actually being congruent to each other, which we'll discuss in a later section in another unit. But in short, the two blue angles are the same measurement, the two red angles are the same measurement. It's not just angles that are across from each other, though. They have to be on straight lines and across from each other. That's the key. So let's take a look at exercise 1. I've given you a grab bag of angles. Some pairs of these angles are complementary, meaning they add to 90 degrees. Some are supplementary, meaning they add to 180. I want you to pause the video and see if you can find any pairs. Pause the video now and see what you can do. All right, let's talk about these pairs of angles. So right away, my method for approaching this problem was to start looking at angle A and see if there's anything that is complementary or supplementary to it. In other words, what plus 36 makes 90? What plus 36 makes 180? Well, 54 plus 36 is going to give us 90. And it just so happens that angle D fits that criteria. So we can say angle A and angle D are complementary. What if we want it to be supplementary? Well, 36 plus 144 would give us 180. Do we have a 144 degree angle? Yes, we do. Angle E. So angle A and E are supplementary. Now we can move on to the next angle and ask ourselves the same question. What plus 116 would give us 180 degrees? Well, 116 plus 64 would give us 180 degrees. So B and F are supplementary. We can keep going around asking ourselves, what plus 54 would make 180? It'd be 126, but there's no angle like that. We could ask about angle H. What plus this would make 90 degrees and 180? Well, we would need a 58 degree angle, which we don't have, and we would need a 138 degree angle, which we don't have. We can keep going around, but the more we look, these are the three answers. These are all the angles in this diagram that are complementary and supplementary. Let's take a look at exercise 2. So in exercise 2, we are told that angle 1 and 2 are complements. If angle 1 is 16 degrees, find angle 2. So we have to remember that complementary means the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And in this case, we know that the measure of angle 1 is 16 degrees. So we're really asking 16 plus what makes 90? Well, to solve, can't we just subtract 16 degrees from both sides? These end up canceling, and we get our answer. The measure of angle 2 equals 90 minus 16, which is going to be 74 degrees. Perfect. What if I give you like part B? Angles 3 and 4 are supplements. We have the measure of angle 3 as an expression, and the measure of angle 4 is a different expression. We need to find the measures of both these angles. Well, we obviously have to solve for x before we can figure out what the actual measure of 3 and the actual measure of 4 are. But how do we do it? It's this word supplements that tells us. Angles are supplementary if they add up to make 180 degrees. So we know that the measure of angle 3 plus the measure of angle 4 has to equal 180. In the problem, the measure of angle 3 is written as 6x minus 46. The measure of angle 4 is written out as 5x plus 6. And that's supposed to equal 180. We just have to combine like terms and solve. So 5x plus 6x is 11x. Negative 46 plus 6 is negative 40. And we get our 180 degrees. From here, we can add 40 to both sides to get 11x equals 220 degrees. And then divide both sides by 11. X equals 20, like so. Because 20 times 11 is 220. Perfect. What do we do with this? Well, we now need to plug this 20 back in for x. So let's do it on both these expressions. The measure of angle 3 is 6 times 20 minus 46, which, when we do this is 120 minus 46, which gives us 74 degrees. On the other hand, if we wanted to solve for the measure of angle 4, the measure of angle 4 is 5x, which we'll write as 5 times 20 plus 6. That's just going to give us 106 degrees. If you want to check your answers, check to see if these two add up to 180. 74 plus 106 is 180, so we are good to go. Exercise 3 asks us to use this diagram to answer the following. In this diagram, we've got a couple straight lines and a couple of rays poking out from them. It first asks us to list all linear pairs. Then we have to list all vertical angles. Then see if any of these angles are complementary or supplementary. So pause the video here, see what you can do, and then unpause when you're ready. Let's talk about this one. So when we're talking about linear pairs, a linear pair is two angles that combine to make a straight line. They add up to 180 degrees. So the best way to find them in a diagram is to look for a straight line. I see that there are two straight lines in the diagram, one of which is right here. So let's start here. What two angles could add together to make this straight line? We could do 1 plus 2 plus 3, but that's three angles that would be combined to make this straight line. You might be tempted to say, oh, then just 1 and 3. But in order to be a linear pair, you need to have two angles that are adjacent to each other. 1 and 3 are not next to each other at all, so that wouldn't work. Instead, look at the other side. On the other side, we have angle 5 and angle 4, which make up this perfectly straight line. So angle 4 and angle 5 would be a linear pair. We do have a second straight line, though, in blue. There we are. So when it asks us if there's another linear pair, again, we can look down below and we get angle 4 and angle 3 combining to make a straight line. So angle 3 and angle 4 are our second linear pair. Perfect. Now it says to list all vertical angles. Be careful with the definition of vertical angles. It's not just two angles that are across from each other. It's two angles that are across from each other on two straight lines. So you need two crossing straight lines in order to make this work. That means this ray here has nothing to do with our vertical angles. Angles 1 and 2 are eliminated. So do we have a pair of vertical angles? Two angles across from each other right now? Yeah. Angle 5 and angle 3 are across from each other, and those are angles that are made up by two straight lines that are crossing. So angle 5 and angle 3 are vertical angles. Perfect. Now it asks if any of these angles are complementary or supplementary. And it's tough because we don't have angle measures. Complementary means that the two angles would combine to make a right angle. But supplementary is even easier to find, because if two angles are supplementary and add to 180, don't they have to make a straight line? If you have linear pairs, you automatically have supplementary angles. So angle 4 and angle 5, angle 3 and angle 4 are supplementary, since linear pairs are made from supplementary angles. Very nice. Now let's take a look at the last problem, which unfortunately has a diagram that's kind of tough to see. I tried to make it a little bit more clear, but it's sort of tough. Folks, in this diagram, we have a bunch of willow branches. Willow cuttings, I should say. Willow is an extraordinarily hardy tree. It can grow pretty much anywhere. So what people have done since medieval times, and people still do this down south especially, is they will make living fences out of willow. What you'll do is you'll plant some willow cuttings in the ground at an angle, sort of like you see these branches are at angles, and you're going to weave them together, and it makes a beautiful lattice. And the good news is these living fences will keep on growing. In this living fence shown, the large angles that we see in the diagram, like this one, and this one, and this one, and this one, are twice the measure of the smaller angles, like this one, and this one, and this one, and this one. And we need to find the measures of the large and small angles. Folks, you might notice a problem with this. We are given no measurements, not even one. And we somehow have to figure out what their measures are in degrees. This is a common type of problem that we should be aware of. In problems like this, we need to come up with a game plan. So, looking at this diagram right here, we notice there's a couple things that we could make. We have some vertical angles that are happening because these are two straight lines crossing. And if we really wanted to, we could cover up one of these rays to make a linear pair. Let's start there. Let's start with the fact that we get to make a linear pair. So I'm going to cover this up with my finger. We know that these two angles, which I will call angle 1 and angle 2, are a linear pair because they make a straight line. That means they have to add together to make 180 degrees. Now, we don't know the measures of these angles at all, but we are told something interesting. The large angles are twice the measure of the smaller angles. We don't know what the smaller angles are, otherwise we'd be able to immediately know what the large angles are, but we can represent the small angles with something. Folks, we have an unknown here. The small angles we can represent with x. So what would twice the measure of the smaller angles be? Well, angle 2 would be twice the measure of x, which we write as 2x. In other words, the two things that add together to make 180, the measure of angle 1 plus the measure of angle 2, we actually can represent both of these in an equation. This would be x plus 2x equals 180. Okay, let's solve it. X plus 2x just gives us 3x. And when we divide both sides by 3, we actually find the measure of x. X is 60 degrees, which we used as the smaller angle. So we can say the small angle is 60 degrees. And since the larger angle is twice the measure of the small angle, the large angle is going to be 120 degrees. So that's how we would solve a problem like that. With that being said, folks, we are all done with section 1.6. Thank you so much for listening. We have finished Unit 1. So have a fantastic rest of your day.